Hello everyone, welcome back to Sulekha physics classes. It is the most easiest way to learn all the concept of physics through this class. Hope you all are doing good. Today I am going to discuss about one last important topic of this chapter, that is propagation or combination of error. What is this? You know, result of an experiment is measured by performing different mathematical operations, right? Like addition, subtraction, multiplication, division. So how errors propagate in these mathematical operations? So today I will discuss about propagation of error in these mathematical operations. Okay, so let us start today's topic, propagation or combination of error. First, I will discuss about error in sum, right? Addition. When two quantities are added, then how errors propagated in case of addition, right? Suppose A and B are two physical quantity, right? And let delta A and delta B be their corresponding absolute error when you measure A and B. Now, measured value of A becomes what? Final result of A becomes? Final result of any physical quantity is written as its true value. True value is A and plus minus delta A. Error may be positive or negative, but it is always added. Okay, so A plus minus delta A. Measured value of B becomes what? B plus minus delta B. So let's suppose that addition of this A plus B becomes Z, right? And also let, when you add these two quantity, errors is also added, error also comes in the result. Let delta Z be absolute error in measurement of Z, right? Z. So what is the value of this delta Z? Absolute error in the final measurement, final result, right? So how you calculate this one? This Z is A plus B. When you add error, measured value of Z becomes what? Z plus delta Z. Measured value of A becomes A plus delta A. You can write plus minus, okay? And measured value of B becomes plus B plus minus delta B. Now this A and B, this A plus B becomes what? A and B is Z, right? So in place of this A and B, you write Z plus minus delta A plus minus delta B. And this side Z plus minus delta Z. So this Z cancel and this delta Z becomes A delta A plus minus delta B, right? This is the final error in the final result. When you add these two physical quantity A and B, then maximum possible error is delta Z. Either it is added in the final result or it is subtracted in the final result, right? But maximum possible error is delta Z, and it is equal to absolute error in delta A plus absolute error in B. So in case of addition, in addition or sum, maximum error is sum of error in individual measurement, right? This is the maximum error in case of addition. This is sum of max error in individual measurements. How much error in measurement of A and B? It is just added, right? This is the case of addition or sum. Okay, let me be more clear with the help of one example, right? Let us suppose that final measurement in volume V1 is 10.2 plus minus 0.02 centimeter cube, and final measurement volume V2 is 6.4 plus minus 0.01. Now you have to add these two volumes, right? So this one is what? This one is this true value. So here final result is true value plus minus sum of absolute error. Delta Z is what? Delta A plus minus delta B, sum of absolute error individual measurement. So here in V1 error, absolute error is 0.02 and in V2 absolute error is 0.01. So first I will calculate absolute error. So suppose delta V becomes what? 0 plus 0.02 plus 0.01. It becomes 0.03. This is total absolute error when you add these two. Delta V you calculate. Now you have to calculate V. V is what? V1 plus V2. Its true value is what? 10.2 plus 6.4. It means 16.6. So final measured volume is what? Final measured volume is V plus minus delta V, and V is what? Just you add these two true value na, you get 16.6, and plus minus delta V is what? Sum of these two absolute error 0.03 centimeter cube. This is, in this way you add any two physical quantity. In the same way, like addition, subtraction also, because error is always added, either it is in case of addition or subtraction. So please take a screenshot of this one, then I will discuss about error in subtraction, right? Okay, hope you have written. Now error in case of subtraction. Same process, because errors are always added, whether it is positive or negative. Here again A and B are two physical quantity, and delta B absolute error in measurement of A and B. Measured value of A becomes A plus minus delta A, and B becomes B plus minus delta B. Now let Z is the result of subtraction of these two quantities. A minus B is Z, and delta Z is absolute error in measurement of Z. Now final result becomes Z plus minus delta Z, right? And here A minus B. So measured value of A becomes A plus minus delta A, and here you take just minus sign. Then B plus minus delta B. Now this A minus B becomes again Z plus minus delta A plus minus delta B. This Z cancel. Delta Z is equal to plus minus this delta A plus minus delta B. So errors are always added, whether it is subtraction or addition case. Total error, maximum possible error is always sum of error in individual measurements. In this case also you get the same result in case of subtraction also, right? So in subtraction, maximum error is sum of error in individual measurement. So final results becomes this true value plus minus absolute error in the final measured value. Suppose in this case you want a difference between these two volumes. So V1 is this one, V2 is this one. Again you calculate delta V in the same way, because errors are always added, whether it is subtracted or added, right now. So errors becomes this one, same value. Now you have to subtract these two volume na. So this is V1 minus V2. So V1 minus V2 becomes what? 10.2 minus 6.4, 2, 3, 4, 5, 6. This side 6 and then this side 3. Okay, whatever is the result you get, 3.6 centimeter cube when you subtract these two values. Now final measured volume becomes what? V plus minus delta V, true value. So here true value is what? You are subtracted these two quantity na, 3.6 plus minus error is 0.03 centimeter cube. In this way errors propagate in case of addition or subtraction. Final error is always, it means maximum possible error is always sum of error in individual measurement, right? So hope it's clear to all of you. Please take a screenshot of this one. After this, we will discuss about how error propagates in multiplication and division. Now, error in case of product or multiplication. Suppose there are two physical quantity A and B and these two are multiplied, right? And let delta and delta be absolute error in measurement of A and B, and also delta Z is absolute error in Z. Now, Z is A into B. So, final measured value of Z becomes what? Z plus minus delta Z. Here again A, final measured value of A becomes A plus minus delta A, and into B, B plus minus delta B. You multiply these two. Okay, you take A common here in this one. So this becomes 1 plus minus delta A by A. And here you take B common, 1 plus minus delta B by B. And here Z is common. So 1 plus minus delta Z by Z. Right? Now this A into B is what? Z. So this one is cancelled. A into B is this Z, right? So this side 1 plus minus delta Z by Z equal to, you multiply these two, 1 plus minus delta A by A and 1 plus minus delta B by B. First 1 is multiplied with these two terms, so 1 plus minus 1 into this one, delta B by B, plus minus delta A is multiplied with this one, so delta A by A, and then plus minus delta A delta B by AB. When you multiply two very small quantities, suppose 0.2 into 0.3, it's 0.06. It's again very small quantity. So this term may be neglected, right? And this side 1, this side 1, these 1 cancel. So in the final result becomes delta Z by Z equal to delta A by A plus minus delta B by B. Right? So in case of this multiplication of product, this is what? Relative error, right? Absolute error by true value is what? Relative error. So relative error in the final measurement is equal to, this is what? Relative error in measurement of A, and this one is relative error in measurement of B. It means sum of relative errors in the individual measurement. So you can write, in case of this product, in product, the relative error is equal to sum of relative error of individual measurement, right? And the same result is for division also. Okay. Suppose one example. Let measured value in length is, let it is 2 plus minus 0.2, okay, centimeter. And measured value in breadth is 3 plus minus 0.3 centimeter, right? Now you have to find area. So area is what? Length into breadth. So this first term represents its true value and second term represents its absolute error. So you have to find relative error in length, relative error in B, and this relative error in area. So what is true value of this area? Length into breadth is just multiply the true value, 2 into 3, 6 centimeter square, right? Now relative error you have to calculate, delta L by L. What is delta L by L here? Delta L, absolute error in this length measurement is what? 0.2 and L is 2. In the same way you calculate delta B by B, relative error in B, 0.3 and true value is 3. In this way you calculate this one, you get here 1 by 10 and here again 1 by 10, right? So this becomes 0.1 and this also becomes 0.1. Now you have to calculate relative error in area, delta A by A. How you calculate delta A by A? Okay, delta A is what? This relative error in this final result is equal to relative error of this one, delta A by A, division measurement sum, right now. So this is delta Z is delta A. So delta A by A is what? Delta L by L plus delta B by B. In this way you calculate delta A by A. Relative error in length plus relative error in B. So what is relative error in length? 0.1 plus breadth is also 0.1. It becomes 0.2. So from here you get delta A becomes 0.2 into area, and area is what? 6. So it becomes 1.2 centimeter square. So in this way you calculate A and delta A. So final result becomes what? Final result. How you write final result? True value plus minus absolute error. So true value is what? 6 and plus minus 1.2 centimeter square. This is the final. In this way you calculate in case of multiplication, and same process is for division also. So first you take a screenshot of this one. Okay, hope you have written. I'm going to cut this side. Now error in case of quotient or division. Division or quotient. It means suppose there is any quantity A and B and you have to divide these two quantity. So in case of division also, relative error in Z, I am going to write just only final result, delta A by A, relative error in measurement of A plus minus relative error in measurement of B. This is the final result in case of division also. For example, suppose mass is given, example, measurement of mass is given 12.4 plus minus 0.1, and density is also given, this is in kg, and density is given 4.6 plus minus 0.2 kg per meter cube. Now you have to calculate volume. So what is the formula for volume? Volume is what? Mass by density. So this first term represents its true value. So true value, mass is 12.4 and density is 4.6. So you solve this one, you get 2.64. This is its true value, right? Now you have to calculate relative errors in volume. First, after that you calculate delta V. So what is the relative error of M? Then rho, density. In this way you get relative error in V. Right now, relative error in V is what? Relative error of M plus relative error in density. So you have to calculate relative error in mass. So how you calculate? This is absolute error, this is true value. Just you divide these two, you get relative error in M. Right? Okay. So relative error in M becomes what? Absolute error is delta M is 0.1 and true value is 12.4. In the same way, relative error in density, delta rho by rho. Absolute error is 0.2 and true value is 4.6. So you just solve these two. Okay, you get final relative error in volume. You just add these two, 0.1 by 12.4 plus 0.2 by 4.6. You just calculate by yourself, right? Now in this way you calculate delta V. Delta V is what? Whatever you get the sum of these two into V, and V is what? Volume is 12.4 into 4.6 is original volume, V na. So when you solve these two, V is what? V is this value na 2.64. 2.64. In this way you get delta V. So final result becomes what? Final result becomes V plus minus delta V. So V is, you already calculated V, 2.64, and then you calculate delta V from this formula, you get the final result, right? So in this way error propagates in case of division, multiplication, right? One more case, in case of power. If anything is given in power, then how error propagates. So first you take a screenshot of this one, after we will discuss power. Now last one is error in power of any quantity. Let z equal to a to the power n. So how you calculate error in case of power of any quantity? You just take relative error, z is delta z by z, and here a is delta a by, and multiplied by that power. Power is always multiplied in the relative error. For example, z equal to a to the power a, b to the power b, c to the power c. In case of multiplication or division, always relative errors are added na, individual measurement, just power is multiplied. So here delta z by z equal to, here delta a by a, then plus delta b by b, then plus delta c by c. And what is power of a? Small a. So you just multiply this relative error, small a. Here power of b is small b, just multiply. Power of c is small c, just multiply. In this way error propagates in case of power of a quantity. And if percentage error is there, you just multiply it by 100. Relative error into 100, you get percentage error, both sides. Right? So in this way, in case of addition or subtraction, absolute errors are always added in the final result, and in case of multiplication and division, relative errors are added, right? Okay, in short, I am going to write this side. In case of addition or subtraction, delta A plus delta B plus minus. Okay, errors may be added or subtracted. So in case of addition or subtraction, absolute error in the final measured value is equal to sum of absolute error in the individual measurement. And in case of multiplication or division, that is absolute error, delta z by z is equal to sum of absolute error of the individual measurement, plus minus. Error may be positive or negative. So in case of addition, you remember this thing. In this way you find the final error. In case of multiplication, in this way you find the final error. Delta z becomes z plus minus delta a by a plus delta b by b into z. So in this way you find delta z in case of multiplication or division and delta z in case of addition or subtraction. And if power is there, you just multiply by the power. If percentage error is asked, then you just multiply it by 100 in case of this one. Okay. Please take a screenshot. Then I will take one example which includes all mathematical operators. Now I am going to solve two questions based on all these mathematical operations in case of addition, subtraction, multiplication, division or power. Question number 1 is resistance R1 is given 100 plus minus 3 ohm, R2 is given 200 plus minus 4 ohm. These two resistors are connected in series. Now you have to find equivalent resistance. So you know in case of equivalent resistance in series is just sum of these two resistance R1 plus R2. So here true value is what? 100. And here true value is 200. So 100 plus 200, it becomes 300 ohm is its true value. Now how you find error? Delta R, sum of, in case of addition or subtraction, absolute error in the final measurement is sum of absolute error in the individual measurement. Here in R1 error is 3 and in R2 error is 4 ohm. So it becomes 7 ohm. So final resistance or equivalent resistance is RS plus minus delta R. Now you can write RS is what? 300 plus minus absolute error is 7 ohm. In this way you find equivalent resistance, right? In case of addition or subtraction. Now question number 2. Here Z is A to the power 4, B to the power 1 by 3, C to the power 2, D to the power minus 3 by 2. You have to calculate relative error in Z and percentage error in Z. So how you calculate relative error in Z? Relative error in Z is delta Z by Z. Here A, B are in product form, na multiplication is there, and C and D are in denominator, it means division is there. So whether multiplication or division, relative errors are always added, right now. So here you write power of A is what? 4. So power is always multiplied. So 4 into delta A by A, relative error in measurement of A, plus here B, power of B is 1 by 3, delta B by B, plus power of C is what? 2. So 2 delta C by C, plus power of D is minus 3 by 2. So you take here minus 3 by 2, minus 3 by 2 delta D by D. So this is relative error in Z. And if you want to find percentage error, you just multiply it by 100. Percentage error, how you find? You just multiply it by 100. Delta Z by Z into 100. 4 into delta A by A. This becomes percentage into 100% plus 1 by 3 delta B by B into 100% and plus 2 delta C by C into 100% minus 3 by 2 delta D by D into 100%. In this way you calculate percentage error. So this is all about today's topic, how error propagates in case of addition, subtraction, multiplication, division and power of a quantity. Hope you understood. Please take a screenshot of this one. So with this whole chapter 2 is completed, right? So I am going to end today's class. After this, I am going to start class 11th one shot series of all the chapters starting from chapter 3. If you want one shot series, please write in the comment box. I am waiting for that one. Okay students, till then keep revising and stay tuned with this channel. Thank you.